Hi there, and welcome to ReinardSynth episode number 14. And on the bench this time, a Korg 01/W Pro. What's wrong with it? Broken keys, unresponsive buttons, left audio not working, not springy joystick, run down felt under the keys, a yellowed LCD cover. And the backlight is no more. It has ceased to be. Bereft of life.
This is an X
backlight.
Well, I better replace it then.
Oh, yes, you will, you lumberjack, you. The whole LCD repair procedure is very similar to what I did to a Korg T2 in ReinardSynth episode number 4, but there's one big difference. Whereas the Korg T2 sets the LCD contrast in hardware using a potentiometer on the back, the 01W sets the contrast value in software. And actually the voltage is generated by a digital to analog output on the keyboard scanner and microcontroller. This one here, the KSP. Of course, the new LCD display has a different contrast range than the voltage range originally generated. Whereas only a value of 1 resulted in a usable contrast, the other values didn't. So I had to change that and learn a bit about op-amps as well. But enough about what is wrong with this board. Let's see what is so pro about this 01W. The original 01W was released in 1991 as the follow-up to the T series of keyboards, which themselves were nothing more than a souped-up M1. Whereas the T series of synths had 8 MB of uncompressed sample ROM with in total 274 sampled sounds to be used by the synthesis engine, the 01W featured 6 MB of sample ROM with over 374 sampled sounds, so more samples in less ROM. The pro thing about the 01 Pro is that it has 10 MB of sample ROM, where the additional 4 MB contain a new acoustic piano sample. Now, the weird thing is that I cannot find any official statement from Korg about the sample's sampling rate and bit width. And looking at the schematics, actually the 10 MB is more 5 megawords with a word width of 15 bits, not 16 bits. And looking closer, it gets even stranger. Bit 0 from the ROMs go nowhere. I couldn't find anywhere where couldn't find in the schematics where it goes to. So actually only 5 megawords times 15 bits is 75 megabits of samples are used instead of the proclaimed 18 megabits. And also nowhere in the service manual, brochures or other marketing material does Korg state the sample memory in kilobytes or words, the bit width of the samples or the sampling frequency. It's always 18 megabits or 46 megabits for the 01W. They did this, however, for the M1 and T series. But perhaps a clue can be found in the schematics of the 03RW module, which uses the same tone generator IC as the 01W. Here in the schematics, the sample ROMs are split between those that provide 12-bit based samples and those that provide 8 or 16-bit based samples. So this might be how Korg crammed more samples into less ROM by storing them as 8, 12 or 16-bit wide samples depending on the quality needed. Very clever. So, what's on the to-do list? Left audio, I have to recondition the joystick, replace switches on the front panel, put it in a new LCD with an LED backlight, provide 5V for the backlight of course, adjust the range of the contrast control, renew the key field on the Keybed, replace some broken keys, have a new battery placed inside, load all the patches, clean this Zen thing, and of course put it together and test. Okay, so the contrast voltage range is not optimal for the display. To better understand how the contrast is set, let's have a look at the section of the schematics that sets the contrast voltage. Here we see the digital to analog output of the keyboard scanning IC, and I measured it, and the outputs have a voltage between 3.73 volts for contrast value 1 and 4.7 volts for contrast value number 8. This voltage is fed into an op-amp, IC54, which is set up as an inverting amplifier. This means that any positive input voltage is output as a negative voltage, with some multiplication or amplification factor, of course. I measured the output, and indeed, the positive voltage is converted in a negative voltage, which is needed by the contrast input of the LCD. Instead of the positive 3.73 volt for the contrast value 1, a minus 7.85 volt is output. And instead of a positive 4.7 volt for contrast value 8, a minus 9.89 volt is output. Yay! We know that a contrast voltage of minus 7.85 volt gives a good legibility of the LCD. So I want that to be in the middle contrast setting, say for contrast value 4. As you remember, I put a 2.2 kilo ohm resistor between ground and the LCD's contrast voltage input pin. I didn't want to remove it because I'm a lazy bastard, so this complicates things a bit. I need to take into account a voltage divider after the op-amp in my calculations. So let's draw the resulting op-amp and voltage divider and put the formulas against it. I used an approximation for the op-amp output and treat the output as the input of the voltage divider. Now, I put this in an Excel sheet and experimented a bit with the values for R147 and R149, and I get these values for my ideal voltage range. R149 shall be 200 kilo ohm and R147 shall be 250 ohm. Okay, let's do this.